Students, we have seen that the angular function theta can be expressed by theta equals to omega t minus x by v. Okay, this we have seen, and this equation can be written as omega t minus kx. This also we have learned. Okay. So, taking this value of omega, that is omega t minus kx, we can write the value of angular function theta in this way also. It is theta equals to omega t minus kx from this equation as omega equals to 2 pi within bracket omega t by 2 pi minus kx by 2 pi. Okay, just what we are doing, we are taking out 2 pi outside the bracket. So within the bracket, all the terms should be divided by 2 pi. Okay, so what we can write in the next step, 2 pi within bracket t by big T. Big T means the time period, minus x by lambda. What is this lambda? Lambda is the wavelength, and the value of wavelength we have seen its value is k by 2 pi by k. So we are putting the value of lambda as this. Okay. So we have seen how to express the angular function theta in various forms. Alright. Now we will see that what is a phase. Okay. So from the equation of progressive wave, it may be written in the form y equals to a sine theta. What is y? Y is the displacement of the particle at position P or any position that you will consider. Okay, this is our basic equation, that is y equals to a sine theta. Alright. So we can put the value of theta as, that means this theta as y equals to 2 pi, theta's value is 2 pi by lambda Vt minus x. Okay. Because we have seen in the previous classes that the value of theta can be written as 2 pi by lambda within bracket Vt minus x. Okay. So if a progressive wave is not damped, that means no moisture part or somehow the wave is completely dry, it is not wet. Okay. So the amplitude of vibration A, this is the amplitude, always remain constant. Okay, repeating once again that if we consider the progressive wave is not damped, that means the wave that is propagating is completely dry. So then the amplitude A of this equation will always remain constant. Except amplitude, all other information about the wave obtained from this angle theta, that is the angular function theta, are this angle theta is called the phase angle or the just simply phase. Okay. So what we have seen, that just the amplitude will remain constant, and from the values that all other information can be obtained from this value theta. Okay. So since this is the phase we have seen, so from the values of lambda and big V, that means lambda is your wavelength. Here I am writing lambda is your wavelength and big V is your wave velocity. So if this is the phase angle we can consider, so from the values of lambda and big V we get frequency, that is small n, we are terming frequency, we are denoting small n for this frequency. So small n equals to v by lambda. And the time period, what will be the value of time period? Equals to 1 by n. I told you, so the value of t will be lambda by v. Okay. Okay. So all these informations we can get from the phase. Now let us see what is the phase difference. Okay. So from the name itself, you can understand the difference of the phase will be your phase difference. Okay, that means the difference of this thetas. Okay. So we can learn the phase difference in this way, that the phase difference of two particles, that means here we have to consider two particles at any two position in the progressive wave. Okay, suppose the progressive wave is traveling here. Okay, so the wave is traveling in this direction, so we have to consider two particles at any two positions in the progressive wave is the difference of the phase angles. This is the angle at two position at that particular instant. Okay, so let us write it in the form of mathematical way. I'm just rubbing it out here. Okay, so if x1 and x2 be the position of the two particles and on the direction of the progressive wave, our wave was like this. Okay, just assume this to be as your one-dimensional axis and it is propagating, the wave is propagating in this direction, that means along OX. So if x1 and x2 are the position of the two particles around the direction of the progressive wave, this we have to assume, x1 and x2. Okay. So the path difference of the wave between the two particles is x2 minus x1. This is the path difference. Okay. So from the equation that we have seen that at an instant t, the phase of the two particles are respectively can be written as in some form of equation.